This movie is for Algebra, Unit 6, on solving systems of equations, learning Target 1. So our first example here would be a word problem. When you're solving a system of equations, you're solving at a time where you've got two variables and you need two equations to solve it. This is an example of that. A farmer had some hens and some pigs. Hens will let be H, pigs will let be P. Altogether among his poultry and swine there were 72 legs. So I know that with a hen, I have 2 legs, and with the pig, I have 4 legs. And together, they have 72 legs. So I've got one equation, but I have 2 variables. Now I'm also given that there's 26 heads. So I know that a hen has 1 head, a pig has 1 head, and I've got 26 heads altogether. This is an example of a system because I have 2 variables in 2 equations. There are going to be 3 ways that we're going to solve a system in this unit. One way is by graphing, another way is using substitution, and a third way is using elimination. So what is a system of equations? It's 2 or more linear equations together, the same number of equations as variables, and then you can solve for each variable. When you graph a system of linear equations, you will get one of these 3 different situations. You will get an ordered pair, and that tells you you have one solution. Where the 2 lines intersect will give you one solution. It is the point that both lines share. So that ordered pair right there is the one solution to that system of equations. You are looking for overlap between the 2 lines. You will have no solution if the lines never intersect. So you know that lines never intersect if they have the same slope. Because lines will be parallel. You will have infinitely many solutions if the other line is directly on top of the first line. So they share every single point on the line. Therefore, we call that infinitely many solutions. So you will either get one solution, which will be an ordered pair. You'll get no solution because the lines do not intersect, or you will have infinitely many solutions because it ends up being the exact same line on the graph. What does the solution to a system of equations look like? It could be a point, which would be an ordered pair where the graphs intersect, or it could be a line where the 2 equations are equal. If there is one variable, there is one equation and we can solve it. We've dealt with that. For example, 2x plus 3 equals 16. That's a line. We know that. We can subtract 3, divide by 2. We can solve it. If there are 2 equations, 2 variables, like our example at the beginning with pigs and hens, you would need the same number of equations that you have variables in order to solve. And if that's the case, you can solve by using graphing, by substitution, or by elimination. Let's prove that the solution we have here is the solution to the system. In number 1, what makes it a system is that I have 2 equations, both with 2 different variables in them. The solution is 2, 3. That tells me my x is equal to 2 and my y is equal to 3. So I plug 2 in for x and 3 in for y, and I get 3 equals 3. True statement, I know it's a solution to this first equation. I plug in my 3 in for y and my 2 in for x here, and I get 3 equals 3. Another true statement, so I know it works for that. If your solution works for both equations, then you know it is the correct solution to the system. Pause the movie, try number 2, press play when you are finished. All right, you plug negative 2 in for x, you plug 3 in for y, so you get 3 equals 1/2 of negative 2 plus 4. That will give you 3 equals 3, true statement. Here you get 2 times 3 plus 2 times negative 2 equals 2. And this is going to give you 6 plus negative 4 equals 2. 2 equals 2. It works for that one. So this is the solution to the system. Pause the movie, try number 3, press play when you are finished. All right, we plug 3 in for x, we plug 2 in for y, and we get 3 minus 2 equals 1, 1 equals 1, it works for this one. And we get 3 equals 1/2 of 2 plus 2, 3 equals 1 plus 2, 3 equals 3, it works for this one as well. So that is a solution. We verified that it is in fact a solution. Let's look at this one. State whether the graphs have one solution, no solution, or infinitely many. Look at the first one. These two lines, do they intersect? Where do they intersect? Well, in looking at these two lines, they never intersect. They are parallel, so this has no solution. Look at these two lines. We have this line here and this line here. They do intersect. They intersect right there. That ordered pair that we get, where they intersect, is our one solution. Now, be careful with this. When you have one solution, write what that solution is. So, for example, this is at, I think it's at 1, 3, or close. That is your solution. 1, 3. Not writing one solution. Well, if you were told there were two lines here, one on top of the other, we would say that we have infinitely many solutions. Because all the solutions with one are shared with the other. Let's solve this system by graphing. Now, fortunately, each one of these is written in slope-intercept form. It makes graphing a little easier. So my y-intercept here is -1. Plot that. I go up 3 to the right one, up 3 to the right one to plot my points. That gives me this line. Let's do the next one. Y-intercept is at 4, and my slope is -2, so I go down 2 to the right one, down 2 to the right one, so on and so forth. That gives me this line. My solution to the system is where the two lines intersect. So my solution is at 1, 2. So it's when x is 1 and y is 2 that I have a solution to this system. Let's try that again. Pause the movie, try solving this system on your own. Press play when you are finished. Okay, let's graph both of these. My y-intercept is at 2. My slope is a -1, so I go down 1 to the right one. I get this line. My second line is +2. I've got a slope of 1. And I have my two lines. Where they intersect is my solution to the system. So that solution is at 0, 2. When x is equal to 0 and y is equal to 2, I have a solution to the system because it's the point that is shared between the two lines. Now keep in mind, you might be able to graph, you will be able to graph a line that's not written in slope-intercept form. It just might be a little easier to change it to slope-intercept form to graph it. Let's look at a word problem. You start with $20 and you're earning $5 per hour at home for the work you do at home. Your friend does not start with any money but earns $10 an hour for the work she does at her house. How many hours will you and your friend have the same amount of money? So writing a system of equations, I have myself, which I'll put as me, and I'll use F to represent my friend. Now in my situation, I start off with $20 and I'm earning $5 per hour for myself. Now, my friend does not start with any money, but earns $10 an hour for the number of hours that she works. So I set mine equal to hers, and I'm solving this system. After how many hours will you and your friend have the same number of money? So you can solve that from here. We are going to graph this. We see on the next page we have graph. So the other thing we can do is for my situation, it's going to be y equals the 20 plus 5m, or x. And then for my friend, she just has y equals 10x. So you can see that when we're trying to find the number of hours that we will have the same amount of money, we're seeing where those two things are equal. What we're going to do is to solve it by graphing. So we're going to take each of those equations and graph them. Take the graph paper here. Let's put our axes on here. You know, it only makes sense in quadrant 1 because I'm going to work a positive number of hours. My friend is also going to work a positive number of hours. And then our income, we're going to see where it's the same. So we've got our total income and we've got number of hours that we're working. For me, I have 20 plus 5x equals y. So I have a y-intercept of 20. For my friend, she's got y equals 10x. So I'm going to graph these two separately. Now I need a good scale. So on my axes, I'm going to increase by 5. 10, 20, 30, and I'm just going to write every other one. This is still a scale of 5 because I'm increasing by 5. And down here, I'm going to do 0.5. Which I'm writing every other one. It still has a scale of 0.5. I'm going to graph my equation, which is 20, and I increase by 5 each hour. So I go up 5 for 1 hour, up 5 for 1 hour, so on and so forth. Now I'm skipping 2 because of my scale. My scale is 0.5. So I've got that line. My friend is y equals 10x. So it starts at 0, goes up 10 for every hour, goes up 10 for every hour. So I'm going up 10 for every hour, and then I've got these points. To solve this system, we are looking for the point that is shared between both of them. And the point that is shared is for 4 hours, we have an income of $40. Going back to the question, it says, after how many hours will you and your friend have the same amount of money? So the answer to that question is after 4 hours, we will both have $40. And that's how you would answer that. That's how you can solve that system using graphing. I'm going to leave this one for some contract work, and that is the end of our